Okay, we are recording and we're mutually exclusive, which is we've been mutually exclusive for everything except that one day last week. Was it last week? We were when we did the lab. Whenever
Yeah, when we were together.
yeah, we were together. Normally we're not together, but we're so that's kind of what you're thinking when you think of exclusive, you're like apart. But
Look, today math inspires me.
well, I got my Pitt Panther jersey on, so I don't know. Yeah, I guess she wins.
So our learning objective today is to explain why two events are or are not mutually exclusive. And so we kind of mentioned I can't talk. We mentioned
Words are not your strong suit. We talked about this the other night a little bit, but didn't get too far along. So let's
appreciate you.
Yeah, no, I'm here to lift you up. And we'll do some essential knowledge because everybody loves essential knowledge.
I feel like they love it. I feel like it's their favorite part of every video.
No, it really isn't. The Mr. Bobby-izing of the essential knowledge.
Okay, I'm ready to read it and you're ready to Mr. Bobby-ize.
No. Why don't we Miss Young it tonight?
No, because you're so good at what you do.
Okay.
So here's your challenge. The probability that events A and B both will occur, sometimes called the joint probability, is the probability of the intersection of A and B, denoted P parentheses A, some crazy upside down U, and a B.
Oh my gosh. All right, like there's different things that can happen. Like I'm gonna wear shoes. I'm gonna wear crazy shoes like 99% of the time. Okay. But I'm probably not always going to wear a Corgi t-shirt. I do have a lot of Corgi t-shirts because I do have my Corgi. So there's like two different things, and the chances of them happening at the same time is what we're talking about. Okay.
Yep. When two things occur at the same time.
Two different things at the same time.
Mm-hmm. Yeah. So there are girls and there are teachers and then there are girl teachers. Yeah. So the girl teachers would be the intersection of teachers and girls.
Yep.
Two events are mutually exclusive, also known as disjoint, if they cannot occur at the same time.
I don't even know if we need to Mr. Bobby-ize that. Like, I can't do two. I mean, I can't eat at Pizza Hut and Domino's at the same time, right? I get like two different.
Wouldn't it be weird though if that? You know how sometimes you go and there's like a Taco Bell and a Pizza Hut and they're the same restaurant?
Yeah, but those are gross.
But also, wouldn't it be weird if it was like a Domino's and a Pizza Hut? Like,
yeah, that would probably not be so good. But like, so something that cannot two things that cannot happen at the exact same time are called mutually exclusive.
Right. So, and then this notation is just saying like, if they can't happen at the same time, then the probability of them happening at the same time is nothing. Which is
talking about that. Something that can never happen has probability 0.
Yeah.
All right. So we're going to be talking about this in terms of tables and graphs and Venn diagrams. And Venn diagrams are my absolute favorite, which is said.
He loves a good Venn diagram.
No, I really don't. And I was like that.
Okay, so we're just repeating what we said a minute ago, disjoint events, and really the language goes back and forth. So disjoint, also known as mutually exclusive, have no outcomes in common and can never happen simultaneously. If we were going to model disjoint events or model mutually exclusive events with a Venn diagram, it would be two circles that never touch.
Okay, I gotcha. I can see that.
If I were going to talk about the probability of A or B, also known as A union B, I could just add those probabilities together. If I were going to talk about the intersection, so that's this upside down U of the two, or the and, the probability would be what, Mr. Bobby? Right, because they're not touching, they have nothing in common.
I'm not touching you, I'm not touching you, I'm not touching you.
You're right. So, a cooler contains 20 bottles made up of 8 Cokes, 5 Pepsis, and 7 waters. The probability of choosing a Coke or a Pepsi is 8 out of 20 plus 5 out of 20 or 13 out of 20. Simple. But if I ask you to find the probability of a Coke and a Pepsi, Like I reach in, what's the probability of a Coke and a Pepsi? Now I can only grab one drink. It's not possible.
Well, yeah, they can't happen. If I'm going to grab one drink, they're two different things.
Right.
So.
Unless you poured Coke and Pepsi into one can and then.
Oh no, we're not doing that. Oh, that's gross. And I think Pepsi is self-floral. I'm gonna have now. I gotta Google
it. Pepsi's.
What is the plural of Pepsi?
Hey Siri. Oh, I was just kidding. Watch. Sorry.
Yeah, I can do it on my phone while you're teaching.
Okay. So the general addition rules says that if two or more events are not disjoint, the above formula doesn't work. So all we've done up to this point is that if we use the word or, we can just add the probabilities together. Probability of A plus probability of B gives me probability of A or B. The problem is if
you were right. You were right. Look.
Pepsi's?
Yes, you were actually right. Of course, that's according to Wikipedia. So, you know.
If they share something, if they have something in common, then I cannot just add the two probabilities together. Because what happens is I add the probability of A, and then I add the probability of B, and I added this middle region twice.
So you just take it away once.
I got to take one away, right? So I add the probability of A and B, or the probability of A plus the probability of B, and then I take away the probability of A intersect B or A and B, okay? So let's look at an example.
Miss Young loves doing it this way because of the formulas, but there is kind of an easier way to think about it when we get down.
Yeah, so on your AP
formula sheet.
It's been a day. On your AP formula sheet, it's actually there. Like the probability formulas, probability of A plus probability of B minus probability of A intersect B is on your formula sheet. So I'm showing that to you because I want you to understand that it's there and you can use it every time, okay? So in a class, there are 12 boys made up of 8 seniors and 4 juniors. There are also 8 girls made up of 3 seniors and 5 juniors. Find the probability of choosing a boy or a senior. A boy or a senior, okay? So the problem is if I just add the boys and I add the seniors, what have I done, Mr. Bobby?
You have 12 boys and 11 seniors. That gives you 21 when you add them together, but you only have 20 students total. So you're double counting the boy seniors or the senior boy.
Right, the senior boys. Yep, exactly right. So I'm going to let Mr. Bobby kind of talk about the visual aids because you can see there that I said the probability of a boy, and the probability of a senior, and then the probability of a boy senior. And then you take that away.
So I'm going to do a little bit of highlighting here, I think. Okay. And we want the seniors right across here, right? And then if in a strange, rare occurrence, I'm going to use a color other than pink. Those are the boys. Okay. So what do I really want is I'm going to outline this in green. What I really want are these right here. Okay. Those are all the boys. And I think, okay, good. Now you can see it. Those are the boys and the seniors. So how many of those are there? There are 4, 8, and 3, and that adds up to the 15 that Miss Young got by doing the formula. So I really am just going to try to highlight. I always just like to trace them out in my pencil, or you're not allowed a highlighter on the AP exam, so you can like outline the boxes.
And this will show you how different people think. So when I look at this table, what I do is I say, okay, boys, there are 12 of them, 8 plus 4. Okay, seniors, there are 11 of them, 8 plus 3. Oh, I added that 8 twice. I probably should only add it once. So I would say exactly what he just said, 4 plus 8 plus 3. But in my mind, it would look like 12 plus 11 minus 8. That's what it would look like. So it doesn't matter how you think about it. You just have to make sense out of it.
I think I've highlighted too much now.
Yes. You want to talk about the Venn diagram?
Do I want to do it with a Venn diagram? Not really, but if you want me to, I can.
I would love for you to talk about the Venn diagram.
Okay. So what we have, I mean, right here, these guys in the middle, those are the senior boys that we would take away. Okay. So we would, if we compare all of these, there are 12 boys, right? We know there's the 12 boys. And if I switch to another, I feel so weird using a color other than pink. The seniors are, there's the 11 all told, but this little wedge in the middle, and I don't know what you call that, the crescent thing or whatever, this part, we're counting it twice.
Mm-hmm.
So I got to like take at least one of those away.
How about just one?
Yeah, I just took one away.
Yeah.
So I'm going to take away, I have the, and that's basically counting what she's got here. It's just a visual of what she's got there.
Yeah. Yeah.
Okay.
So there's kind of 3 or 4 ways to think about this problem. And some people love the Venn diagrams, and some people love the tables, and some people want to do the probability formula. And it doesn't matter, just whatever works for you.
Yeah, if you're a visual person who likes that Venn diagram, that's great. I'm more of a organizer, table kind of guy. That's my thinking process. Miss Young might be a formula person, and you know, she's fine with that. Ooh, kitties.
And puppy.
Oh, I thought that one on the left was a unicorn. It's his tail.
Okay, you ready, Mr. Bobby?
I just want the unicorn cat now.
I need you to focus.
Okay, we'll focus. We're gonna make the table this time, I assume. Okay, because I'm a big old table kind of guy. So we have, if we read the problem, we have 25 pets, 16 dogs, and 9 cats. There are 13 puppies and 6 kittens. Then the pet is chosen at random. We want to find the probability. So we're going to make the table. And so what we're going to do is I'm going to decide, do we want to put cats or dogs across the top or the bottom? And I guess I'm going to put cats on the top because you know why? I get to decide. So I'm going to say cat up here. Okay. So actually, I'm going to not put it there. I put that wrong. You made a bad face at me and I knew it immediately. So I'm going to put cat here. Okay. And I'm going to put kitten. Wait a second. This is going to be adult. And infant or child, whatever, cat, dog, youngin.
Youngin.
Okay. Well, you're young. Yeah, you're young. Well, you're.
Yeah, I think that says yug.
Young. I know, but I kind of got messed up. All right. So how many adult cats are there? There were, it doesn't tell me. No, but it does tell me there are 6 kittens, right?
Mm-hmm. And it tells us there are 9
total.
9
I need to have,
total.
yeah, I have to do a total here. Okay. I don't know why my iPad is not helping me today. So there's 9 here. So if I know the total and I know there are 6 younglings, that means there's got to be 3 adults. Okay.
I'm in agreement with you.
Okay. And then I'm going to put dogs over here. And I need to figure out, I know there are a total of 16 dogs. And we are told that there are 13 young dogs or puppies. And that means there would also be 3 older dogs. I made a table. You could have made your table look a little differently than mine, but I decided to put cats and dogs across the top. And I wasn't going to make a big difference, but they're either fully grown or we call cats and dogs kittens and puppies. That's the young version of the animal.
I like that you just explained that to them like they didn't know what kittens and puppies were.
Well, you know, whatever. That's my logic in making my table. I wasn't trying to explain to them that you're the one who doesn't have cats. You're heartless.
Heartless, I'm allergic. There's nothing I can do about that. Okay, so let's do
I
some
still want the
probability then, Mr.
unicorn.
Bobby.
Okay. So what we want to do now is we just pick we go in there, we close our eyes and point at an animal. Okay. Um, and we want to find out if it is a dog. And by that, we're assuming a fully grown. Okay. By my table. Where would these folks be? They would be the three that I have right here. So that would be 3 out of the whole kit and caboodle. See what I did there?
Actually, that's
3 out of
fun. Except for it's kit and caboodle,
kit and
not
dog boodle.
kitten.
Whatever. Whatever. And is that a dog? Is that a Newfoundland in the middle there?
I don't know. I have no idea. I just stole this
Little
off
dog.
the internet.
Oh yeah. Well, and then for a fully grown cat, it would also be 3 out of 25 because there are only 3 fully grown cats. All right. What's the chance of getting a puppy? Well, that would be since we don't know, a puppy is a young dog. That would be 13 out of 25. And a kitten would be a young cat, which would be 6 out of 25. And I don't think any of those fractions reduce, but I don't really care because I'm going to not waste brain power doing it. So even if they did, okay. All right, so them's the easy ones. Now I want to figure out the puppy or a kitten. Can there be puppies and kittens? Or can it be a puppy or a kitten? Yes, it's not an and. Okay, I can't. I
No, if
can't
I had asked the
and
question,
a kitten. Okay, because they're like two different. And no, we're not gonna mush two.
a bitten,
We're not. Don't even try to like come up with some gross way of melding a puppy and a kitten because that makes you a bad human being. Okay.
kippies.
So I want the young cats and the young dogs all told together. So that would be 6 plus 13. I'm just counting them up. I'm looking at that second row over 25. And if I were to simplify that, it would be 19 out of 25. Oh my gosh. You want a dog?
No. All right, neither a puppy or a kitten. What do we do?
Now we want the old ones. That would be 6 and 6, or 3 and 3. So that would be 3 plus 3 over 25, which is 6 out of 25.
Is there another way that we could have done that?
Probably. You're going to tell me that I did it wrong.
You didn't do it wrong.
Okay, well, I mean, I could have taken away the number that I just did a minute ago. I could have done 1 minus 19 25ths. Because I found the probability of getting a puppy or kitten. I could just do the flip thing that we did the last time. Take it away from 1.
Also known as the compliment. When Miss Young is pretty.
Oh my gosh.
You said it, not me.
My dog's over here passing gas. Like we're doing dog. Seriously, I mean, it's really.
All right, real quick. So kind of what we talked about here is like make a table. It's super helpful. It makes problems super duper easy. Or make a Venn diagram. That also can make a problem super duper easy. Remember that if you are doing an or problem and they're not mutually exclusive, you have to subtract away that intersecting piece because you don't want to add it twice. And that if they are mutually exclusive and they have nothing in common, that when we do the probability of A and B, that probability is 0 because they have nothing in common. Okay, and let's look at this. I think this might be even the last problem. I could be wrong though. So it says, what is the relationship between educational achievement and home ownership? A random sample of 500 US adults was selected. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. The two-way table displays the data. Suppose we choose a member of the sample at random to find events, okay? So we're looking at G being a person that is a high school graduate and H being a person who is a homeowner. And he's just giving us some totals here so that we can talk.
Keep going.
Remember that we should be able to add the totals across the rows and down the column and get that 500 that's in our prompt as a total if we did this correctly. Okay. So first question says, explain in plain language what the probability of G complement means, and then find that probability. So remember, G is a person who is a high school graduate. So what is a G complement?
That would be a person who, the opposite of that. So that would be someone who did not graduate high school.
Yeah. And so if we want the probability of a person that is not a high school graduate, what would we do?
Well, we know that there are 310 high school graduates, thanks to my wonderful math abilities. So I could take 1 minus 310 over 500, or just go straight down because I added them up and got 190 non-high school graduates. So it would be 190 divided by 500.
Yeah. Okay, so how about this one, Mr. Albee? Explain why P of G or H is not equal to P of G plus P of H this time. So why can I not just do straight addition of probability? It's an or problem.
Because G is high school graduate and H is homeowner. There are high school graduates who are also homeowners. That would namely be those 221 people in the upper left corner.
Right. So if I find P of G or H and I add 310 and 340, right? I add the total for high school graduate, 310 out of 500, and I add the homeowners, 340 out of 500. I've added 221 twice. So I have some options. I can do 89 plus 221 plus 119.
That's how I would do it.
Or I add 310 plus 340 and subtract 221.
And that's how probably my wife would do it. And that's fine.
Yeah.
Either way.
It doesn't matter, guys. If you would even rather, this would be a kind of a more difficult, well, no, it wouldn't be any more difficult of a Venn diagram. You can always make a Venn diagram too, if that makes more sense to you. So, I forgot. It's been a minute since I wrote this. Make a Venn diagram to display the sample space in this chance process. Did I? No, I didn't. We have to actually draw it.
Oh my goodness. Now you're going to, all right. And you know, I love me some Venn diagrams, so you're going to have to help me here.
So remember what we were looking at? We're looking at P of G or H, P of G or H. So the probability of a graduate.
So this is G and this is H. All right. And if this overlap, I know is 221.
Right. So that's G and H.
So if they're a homeowner, or if they're a high school graduate who doesn't own a home, that's the 89 out here. That's the G that's not owning a home. And then the high school graduates who are, I mean, the homeowners who are, this would be the 119.
Yeah.
So.
And then you just add those three numbers up. So pretty simple, pretty simple.
Totals worked out pretty nicely too.
Beautiful.
Beautiful.
You
are aside from my sad handwriting.
Beautiful.
All right.
Write the event is not a high school graduate and is a homeowner in symbolic form and find the probability.
Why is my...
Ooh, I did this one. What are you doing?
I'm getting bad internet. My internet message came up.
Oh, okay.
Unstable.
Okay. So if I want to write the probability, probability notation is not a high school graduate, what does that look like?
That would be G complement.
And is a homeowner?
And is the union, right?
Upside down.
Upside around. Yeah, I wrote it the other way around. My bad.
And you know, the way that I remember this, and I do this every time in my head, every single time, I remember that the upside down U is the and because it will make the A in the word and. That's the way I remember it every single time.
Okay. So I got the notation, I got not a high school graduate, not is that complement thing. and
Mm-hmm.
homeowner is RH. So I got my notation here. Now I
Right.
got to find that probability. Okay, so I'm gonna let me erase this Venn diagram here. So I want the the non-high school graduates. So that would be 100, 190,
Mm-hmm.
and they are so those and the ones that are home. That's the 119, right?
Mm-hmm.
That would be these guys right here. I want him and just him, right?
So we want, when we think about, when we think about this intersection and this and it gets really confusing. Yeah, I mean, if you just think about it on the table of, I'm only talking about the intersection, so they have to occur at the same exact time. You have to be both not a high school graduate, and at the same time you have to be a homeowner. So I'm not combining things, I'm looking for where things are in common. That's the difference here, is I'm not combining, I'm looking at where do they meet.
Yep.
Okay.
Or was an ad and is a exclusion kind of thing.
Right. So you get that 119 out of 500 or 0.238.
Why did I write that when you could have just clicked?
I know, because you were doing such a good job. I told you, but you were having internet unstable issues, and so I just let you go. Yeah.
Okay.
So that's it. You're gonna do two-way tables, Venn diagrams, and probability. One Khan Academy to go with this. Look at this pug and this cat. Are they cute? Oh my god. All right, guys. It was super nice chatting. We didn't chat with you, but it was super nice chatting with Mr. Bobby while y'all listen. Bye.